Everyone, we have our last little video lesson. This one is pretty self-explanatory, why changes in y-intercept. So far we have looked at two other different types of transformations that we can do with lines and what we can see in terms of equations. So if you are looking at an equation that has a change in its polarity, we have already seen that our positive slopes become negative slopes. If we look in terms of its slope, in terms of if it's getting steeper or more shallow, we're looking at slopes that go from increasing from 1, so like 2s, 3s, 4s, or even 3 over 2 because that's 1.5 slope, or slopes that become more shallow of like fractional units like 1/2, 1/3, 1/5. So now we're going to look at the last type of transformation. So the last two were rotations and reflections. This last one is what's called a transformation, or translation. So that means we're shifting up or down. So our parent function, y equals x, we've seen this a couple of times. It looks just like this. I'm trying to draw it quickly. This function, how has it changed? So the slope is the same. We have a positive slope of 1, and then our y-intercept is the only thing that has changed. In this parent function, our y-intercept was 0. It is a completely proportional graph, and then it goes through 0, 0. This one, however, goes through 3. So if I were to graph this, it has shifted itself up. Its slope hasn't changed, though. So it still has that 1-to-1 slope, but it has gone through y equals 3. And we have a graph like that. So the graph, our parent function, has shifted up 3 points. So essentially, if I were to graph this right on top of this particular graph, let's see if I can do this, kind of. If we look at that, we have parallel lines. But in all reality, our shift has been a translation up 3 units on the y-axis. Okay, so we have parallel lines that have come out of this, and that's because of our slopes, and our y-intercepts are the only change, but essentially we have a translation up of 3 units on the y-axis. Let's check out what happens if we go down on the y-axis. So again, we have our same parent function that we've been dealing with this whole time of y equals x. And our new equation, I screwed up here with my little writing here, y equals x minus 6. So we're going to start on our y-axis, 1, 2, 3, 4, 5, 6, down to negative 6. And now we are going to graph this with that same 1/1 slope. And connect the dots. When we do that, have the same slope, check that out, same slope, but this y-intercept has changed. So essentially what we can say is we have a translation down 6 units on the y-axis from our parent function. I'd like to do one last problem so you can see how all of these sort of come into play. So let's see what this all looks like if we have a crazy, crazy, crazy scenario where our parent function, y equals x, becomes this equation, y equals negative 1/3 x plus 2. So if we look at this, we need to be able to describe how its polarity has changed. So does it get reflected? Does it get rotated? And does it get translated? So we're going to look at those 3 aspects, and we're going to very clearly break them down. So our base, our parent equation, looks like this if we were to graph it. And our translated, reflected, rotated equation, if I were to write this out, we have a y-intercept of 2. We're going down 1 to the right 3, down 1 to the right 3, up 1 to the right or left 3. And so we have this. Let me see if I can draw this without shifting my paper too terribly much, which I know I already did. So now we have this equation. And so now we can say 3 things. We need to be able to describe how it's changed in 3 different ways. Way number 1 that it's changed, we're going to talk about its reflection. So in other words, has this equation from here changed in terms of a reflection? In other words, do we have a puff positive line versus a nice negative line? And yes, we do. So this line, we would just say, yes, it's been reflected. And we can say it's been reflected, and we can be more specific, and we can say it's been reflected over the y-axis or the x-axis or whatever else, but simply it's been reflected is enough in this case. 2, has it been rotated? And I am again just looking at this slope of 1 versus this slope of 1/3. I'm not looking at the fact that this has become negative 1/3. I'm looking at 1 versus 1/3. How has it been rotated? If I were to look at 1 versus 1/3, because I've already taken care of the reflection, I've already taken care of this negative sign up in front. How has it been rotated? I know that when I have a fractional rotation less than 1, it rotates clockwise. So its rotation has been clockwise. And 3, now we can talk about its translation. How has it been translated? And now we're looking at just the b value. How has that changed? So how has the b value changed? It has increased by 2. That means the translation is it's been translated up by 2 units on the y-axis. And I can be specific and say the y-axis, but I'm going to assume that you know what you're talking about when you say it's been translated up by 2 units. So I'm looking for, yes, it's been reflected, or no, it has not been reflected, just talking about positive versus negatives. Rotated, just let's look at the slope in its absolute value form, so 1 versus 1/3. Has it rotated in what direction? So clockwise versus counterclockwise, and translated 0 to 2, in this case, up by 2 units. But has it maybe gone up or down? Okay? So now I'd like you to practice some of these problems and then try your hand at the exit pass. Thanks for watching.